Alright, so the different parts of a regular polygon, this is the center, this is a side. We just learned that the distance from the center to the side, that makes a right angle, that length is called the apothem. And then earlier we had this polygon inscribed in a circle. What do we call this distance from the center of the circle to the edge of the circle? That's called the radius of that circle. So the distance from the center of your polygon to each vertex is called the radius. And we know the area is 1/2 apothem times perimeter. But this concept of a central angle is if you were to take your polygon and divide it into a bunch of these triangles. So all the way around the circle is 360 degrees. So if this is a regular hexagon in this instance, then all of these triangles are going to be congruent. So all of these angles are going to be congruent. So I would take 360, the total, divide it by the number of triangles, which is the same as the number of sides, which is 6, and I would get that each of these angles is 60 degrees. This is 60 degrees, this is 60 degrees, this is 60 degrees, this is 60 degrees, etc. So if I'm trying to figure out what the measure of these central angles are, I'm going to take 360 and then just divide it by the number of sides of that polygon. So the central angle is 360 divided by the number of sides, and then that would give me like this whole angle up here. So if I just wanted to find this little nugget up here, then I would just take the central angle and divide it by 2, because that little nugget would be half of the whole thing. So keep that in mind. Alright, find the area of this regular polygon. So we know our side length is 10, but we do not know our apothem. So I'm going to have to first find the central angle. So the central angle is going to be 360 divided by 5. So this is my central angle. So 360 divided by 5, because it's a pentagon, it has 5 sides, is 72. And then I'm going to take that 72 and divide it by 2, which is 36. I'm just going to make this little angle 36 up here. Then this regular polygon, when you have your apothem that comes and intersects the side and makes a right angle with the side, it's going to be bisecting that side. So this segment and this segment are going to be congruent. So if this whole thing is 10, then this is 5. And now we have my favorite shape, a right triangle. I have this angle up here is 36, this is 5, and I want to find my apothem, so I'm going to call it x. So I think about my toolbox. So I only have one side, so I can't use Pythagorean theorem. I don't have a special right triangle, so I can't use a 30, 60, 90 or a 45, 45, 90 triangle. I just have a random angle and a side. I'm going to use SOHCAHTOA. So if this is my angle, 5 is the opposite side, and x is the adjacent side. So I'm going to use tangent. Tangent of 36 is going to be opposite over adjacent. So I get 5 over tangent of 36. I get my apothem to be 6.8819. And so now I know if I'm going to try and find the area of this polygon, my formula is 1/2 times the apothem times the perimeter. So the perimeter is the number of sides, which is 5, times the length of each side, which is 10. So the perimeter is 50. So my formula area is 1/2 times the apothem times the perimeter. So 1/2 times the apothem times 50. My area is 172.04, so 172.0 inches squared.